Dear students, we are in the topic complex numbers objective. Level 2 classwork is going on. Until yesterday we have completed 19 sums in level 2 classwork. Let us going to discuss today the sums from 20th question. The complex number Z having least positive argument which satisfies the condition modulus of Z minus 25 I less than or equal to 15. Modulus of given condition modulus of Z minus 25 I less than or equal to 15. The complex number Z having least positive argument which satisfies the condition. You can understand this one as let Z is equal to x plus I by minus 25 I over modulus less than or equal to 15. That implies you can write this one as x plus y minus 25 into I over modulus less than or equal to 15. This can be written as x square plus y minus 25 whole square less than or equal to 15 whole square. Less than or equal to 15 whole square. So, this is the value. Represents a circle. This represents location of interior of circle. Because it is less than or equal to 15. Interior of circle or boundary of circle. Interior of circle or boundary of circle. Concept S11 less than or equal to 0. Boundary of circle having a center. Interior of circle or boundary of circle having a center 0, 25 and radius is equal to 15. 0, 25 is center and radius is equal to 15. Depends upon this concept. Let us draw the diagram. First of all, let us draw the coordinate axis. This is real axis. Real axis means x-axis. This is imaginary axis. Imaginary axis means y-axis. This is 0, 0. Draw here a circle having center 0, 25 and radius 15 put here. This is a point P, is any point on the circle. This is origin O, this is center C. Center CP is nothing but you can understand this is 25. This is radius R. Radius R is 15. So the least argument having depends upon tan theta because argument meaning theta is equal to tan inverse y by x. So let us remember argument formula. Argument theta is equal to tan inverse y by x. Meaning here tan inverse imaginary part by real part. That implies tan theta is equal to y by x. So what is tan theta? So tan theta gives little argument. Depends upon the concept of tangent of the circle. That little argument depends upon the tangent of the circle. So what is tangent of circle here? OP is tangent. CP is radius. We know that angle in semicircle is 90 degrees. If here this is making angle theta. This is making angle theta, then you can understand this place is 90 minus theta. Since this is 90, this can be understood as this place. Let us write properly, in proper way you can understand here. Put P here, this is 90 degrees, this is C and this is, better to take, okay, no problem. This is C, this is O. OC is equal to 25 we got, of course it is hypotenuse. and CP is equal to 15. So you can understand this is 25 whole square, 625 minus 225 becomes 400, 400 root is 20. So you can write here 20. So OP is 20, and here I am going to discuss with you that this is 90 minus theta. Which one at O? This is 90 minus theta. This is 90 minus theta. So what will happen in any triangle, sum of angles is equal to 180 degrees. So you can understand angle PCO is equal to 180 degrees minus of 90 degrees plus 90 minus theta. Why did you write 90 minus theta, sir? Because it is perpendicular. Real axis and imaginary axis are perpendicular. That is why you can write here 90. Whenever this tangent making angle theta with the positive direction of real axis, it is theta, then it becomes 90 minus theta. So this angle we need now 180 minus 180 plus theta. So angle PCO becomes theta. Of course it is theta. So this is also theta. Whatever angle is outside is there, this is also theta. Using this theta, we can write here cos theta is equal to adjacent side by hypotenuse. So it is 15 by 25. Cos theta is equal to 15 by 25, and sin theta is equal to 20 by 25. Sin theta is equal to 25, 20 by 25. We need to calculate P. So let us calculate P x comma y or Pz. Pz is equal to x comma y can be understood as the formula r cos theta comma r sin theta. Here 15 by 25. Yeah, 15 by 25 meaning 5 table becomes 3 by 5. So cos theta is equal to 3 by 5 and sin theta is equal to 4 by 5. So what is r here? The distance OP is r. So 20 into 3 by 5. 20 into 3 by 5. So 12. Option is there. 12 plus 20 into 4 by 5. 16. Yeah, option 4 verified. R meaning OP is equal to R here. R meaning don't think as radius. The point P is R units distance from origin. It is called as R. While polar coordinate system x comma y can be understood as r cos theta comma r sin theta, where theta is equal to tan inverse y by x and r is equal to root of x square plus y square. In that concept, here from origin to P, how much distance is there? It is called as R. So OP is equal to R. OP is equal to R you write now. So you can understand that is equal to 20 into 3 by 5, comma 20 into 3 by 5, comma 20 into 4 by 5. So that is equal to, this is 12 comma 16. Therefore P of Z can be understood as 12 plus 16i. This is the having least argument. Least argument depends upon tan theta. Here tan theta is nothing but tangent of the circle. Now 21st question. First question, if A and B are real numbers between 0 and 1 such that the point Z1 equal to A plus A, Z2 equal to 1 plus B and Z3 is equal to 0, form an equilateral triangle, then A comma B. In the conceptual teaching, while discussing synopsis, I said the formula that Z1 square plus Z2 square plus Z3 square is equal to 3 into Z1 Z2 plus Z2 Z3 plus Z3 Z4 Z3 Z1, where Z3 is origin, then Z1 square not 3 into, for Z1 square plus Z2 square plus Z3 square is equal to simply Z1 square plus Z2 square plus Z1 square plus Z2 square plus Z3 square is equal to Z1 Z2 plus Z2 Z3 plus Z3 Z1. In the concept, if Z3 is equal to 0, you can understand Z1 square plus Z2 square is equal to Z1 Z2. In synopsis we have discussed it. in page number in our material, synopses are there regarding Z1 square, Z2 square, Z3 square like this. Page number 7. You can see the synopsis in page number 7. Okay, Z1 square plus Z2 square is equal to Z1, Z2 is there. Using the formula. Remember this one as a formula. What is Z1 here? Z1 is equal to A plus I. Z2 is equal to 1 plus Bi. That implies, apply the formula here, A plus I whole square plus 1 plus Bi whole square is equal to Z1, Z2 can be understood as A plus I into 1 plus Bi. That implies A square plus 2AI minus 1 because I square plus 1 plus 2BI minus B square because minus B square I square is equal to, multiply here, A plus ABI plus I minus B square PI square. So here minus 1 minus B square. A square minus 1 plus 1 get cancelled. A square minus B square, write in a bracket, plus 2I taking common, within the brackets you can write A plus B, here you write A minus B plus I into AB, I into AB. That implies, now compare real comma imaginary parts. Compare real comma imaginary parts. That implies A square minus B square equal to A minus B comma 2 into A plus B. 2 into A plus B is equal to AB. So now you write this one as A minus B into A plus B minus of A minus B is equal to 0 comma, the relation is A plus B is equal to AB by 2. And you can understand here, if you take common A minus B, within the brackets you can write A plus B minus 1 equal to 0. A plus B minus 1 equal to 0, and if A plus B is equal to 1, AB is equal to 2. Okay, if A plus B is equal to the case 1, here therefore we can write A is equal to B or A plus B is equal to 1. A is equal to B or A plus B is equal to 1. If A plus B is equal to 1 here, you can write AB by 2 is equal to 1. Therefore, AB is equal to 2. Now, verifying options. Verify options. First one, 2 minus root 3 comma 2 minus root 3. So, A is equal to B. If AB is equal to 2, AB means 2 minus root 3 into 2 minus root 3 whole square. 4 minus 3, 1 plus 1 minus 4 root 3. It is not possible. So, A is equal to B, one option is there. Let us discuss about the option. 21 question. First option. Yeah, simply verify option 1, A is equal to B. That implies one chance is there. A is equal to B means both are same. 2 minus root 3 and 2 minus root 3. Next, 22nd question. 22nd question. If the circles modulus of z minus 1 is equal to 3 and modulus of z minus z naught is equal to 4. Circle 1. Circle 1. Circle 1 modulus of z minus 1 is equal to 3. Modulus of z minus 1 is equal to 3 and modulus of z minus z naught is equal to 4. Modulus of z minus z naught equal to 4. Then intersect orthogonally, then what is the option? You can understand according to geometrical theory, first circle can be understood as x minus 1 whole square plus y square is equal to 3 square. This center is 1 comma 0 and radius is 3. Put this is the first circle. And the second circle you can able to understand here, because this is x plus iy and this can be understood as x naught by plus iy naught. So x minus x naught whole square plus y minus y naught whole square. X minus x naught whole square plus y minus y naught whole square is equal to 4 square. This is circle 2. So here center is x naught comma y naught and r is equal to 4. This is second circle. If we draw the diagram regarding the two circles, let us draw x-axis. I mean real axis in the complex language. Real axis and imaginary axis. Put here 1 comma 0. Put here this is 0 comma 0 and you can write here 1 comma 0 and you can write here 3 comma 0 and produce the real axis. This is x-axis. And next one, r is equal to 4 is the first circle, r is equal to 3 is there. So from 0 0 to having center 1 comma 0, from 0 0 to 3. Draw triangle like this. Modulus of z minus 1 is equal to 3 circle is that one. Next he given as x naught y naught, where we don't know, maybe negative or positive or anyway. R is equal to 4 is there. So whenever r is equal to 4 is there, if you think this one, r is equal to 4, this side 4 you can write modulus of z minus z naught he is asking. 4 comma 0 you can put here, and if you write minus 2 comma 0 also. So this side minus 3 comma 0, 1 comma 0 like this, 3 comma 0 and minus 3 comma 0, okay, 4 comma 0, this side you can write. Let us going to discuss about the radius. So draw like this. This radius is 3 and this radius is 4. Draw like this. Whenever two circles are orthogonal, radius, let us going to discuss. Right here this is z0. Z0 is nothing but x0 comma y0 is the center. Z0 is nothing but x0 comma y0 is center. From center to any point on the circle is called as radius. So this radius became 4. And this radius, which one? First circle radius is 3, of course it is 3 like this. From 0 0 to. This is 3. These two circles are, he said that orthogonally. The two circles intersect orthogonally. If you put here the name P here and put here the name Q if it is R, then he given that angle PRQ. Angle PRQ is equal to 90 degrees. Already we have learnt the concept that if two circles are orthogonal, that meaning is the angle between tangents of the two circles are orthogonal. Angle between two circles can be defined as angle between their tangents. So here tangents we have done. Of course the first radius is tangent of second radius is tangent of first circle and the first radius is tangent of second circle, like that. Okay. Then what is happening? Z0 PQ right here. PQ is equal to, of course this is 3 square plus 4 square concept. PQ is equal to root of 3 square plus 4 square concept, it is 5. So PQ is equal to 5 we got. Modulus of PQ is equal to 5. So modulus of PQ meaning here the distance between what he is asking now, modulus of z minus z0 is equal to 4 he given. It is a circle. Then what is the value? So what is the value of, then what is the value? So it depends upon z0. So for the circle we need to calculate. PQ is equal to 5 is there. So Z0 PQ is equal to 5 is there. So of course, according to options, third option, the Z0, the circle, the center should lie between 4 and 6. 5 we got the value. 22nd question. If we put here, okay, Z0 maybe here, if this is minus 2 comma 0, minus 2 comma 0 and 3 comma 0 distance is 5. Minus 2 comma 0 and this one, of course, center, not like this. Like this you draw. This is 3. From center to any point. This is correct. Now, minus 2 comma 0. That implies from diagram I am writing. From diagram. You can understand Z0 minus 1 I am writing. The distance between this center, of course, minus 2 comma 0, don't confirm, simply I had written. Z0 minus 1 we got as 5 because 3 square plus 4 square. Whenever modulus of Z0 minus 1 is equal to 5, you can understand modulus of Z0 minus 1 is equal to plus or minus 5. So Z0 is equal to 1 plus or minus 5. That is Z0 is equal to minus 4 or minus 6. Therefore, Z0 is equal to minus 4 or only 6. You should not say minus because he is discussing with us only modulus of Z0. Therefore, that implies 4 less than or equal to modulus of Z0 less than or equal to 6 you should write. 4 less than or equal to modulus of Z0 less than or equal to 6 is the correct answer. According to here minus 2 comma 0 simply I said don't confirm it. X0, Y0. Don't confirm it. Simply Z0, center is X0, Y0. The distance between Z0 and 1 comma 0, that is the distance between two centers C1, C2 whole square is equal to R1 square plus R2 square concept. So Z0 minus 1 can be understood as that is the concept of right angle triangle according to Radi. This became 5, so modulus of Z0 minus 1 is equal to 5. Then you can understand Z0 lie between 4 and 6. Now 23rd question. Third question. Let Z1 is equal to 8 plus I and Z2 equal to Z1 equal to 8 plus 4a and Z2 equal to 6 plus 4a. Argument of Z minus Z1 by Z minus Z2 equal to pi by 4. Then Z satisfies. Z1 is equal to 8 plus 4a. Z2 is equal to 6 plus 4a. Argument of Z minus Z1. Argument of Z minus Z1 by Z minus Z2. Argument of Z minus Z1 by Z minus Z2 is equal to pi by 4 satisfies. So better to draw a triangle like this. Let the concept I am going to discuss with you regarding the circumcircle of the triangle. Let P here Z you take. P Z. This is Q you write here Z1. This is R you write here Z2. Yet Z1 you can write 8 comma 4. And yet Z2 you can write 6 comma 4. Now, according to yesterday concept, yesterday we have discussed a sum that if here it is an angle alpha, here it becomes 2 alpha. Of course, everybody knows that, no need to discuss yesterday or today. If here for the triangle upper vertex making an angle alpha, at the circumcenter it makes 2 alpha. Pi by 4 given. Z minus Z1 by, according to slope I am discussing with you the argument y2 minus y1 by x2 minus x1 concept, let Z minus Z1 by Z minus Z2 pi by 4. This is the argument. Let here P, Q, R, this is yes, like this. This is yes. So here this becomes pi by 2. Now, according to Coni's theorem, we have discussed that SQ by SR, SQ by SR is equal to modulus of SQ by SR into e power I theta. That is the Coni's theorem. So we have discussed that Z1 by the distance between Z1 by Z2 is equal to modulus of Z1 into modulus of Z2 by Z1 Z2 into e power I theta. It is e power I pi by 2. Of course, we know that for a from circumcircle to anywhere the distance are equal. SA is equal to SB is equal to SC. We know that I am writing, we know that SQ is equal to SR. So modulus everything same will be getting cancelled. SQ by SR. So yes, if we are thinking Z, S is equal to Z, or anyway P, Z he given, Z minus 4 by the concept, Z minus Z1 by Z minus Z2 concept. So SQ is equal to SQ by SR is equal to e power I pi by 2. SQ by SR is equal to e power I pi by 2. E power I pi by 2 meaning cos pi by 2 plus I sin pi by 2. Of course, it is nothing but I. It is nothing but I. So, if you are thinking this is maybe Z or anything, small z, let us write small z. Small z minus 4 by this one, small z minus C meaning here he given as Z1 minus C by Z2 minus C. Z1 minus Z2 SQ meaning Q minus S. So Z1 minus C by Z2 minus C. S meaning we should take 0, 0. Z1 minus C by. Okay, let us write like this. Simply I am writing Z1 minus C, not C, this is S. Z1 minus C, this one, from this side right. Z1 minus C by Z1 minus S by Z2 minus S is equal to e power I pi by 2 meaning I. That implies, what is Z1 here? 8 plus 4i. 8 plus 4i minus S is equal to I into, what is Z2 here? 6 plus 4i. 6 plus 4i minus S. That implies 8 plus 4i minus S is equal to, multiply like this, 6i minus 4, this is I. 6i minus 4. 6i minus 4 minus Si. Minus Si. Minus S taken this side and these terms taken this side. Otherwise, write like this. 8 plus 4 becomes 12 minus 2i. 12 minus 2i is equal to S minus Si. S taken common and you write 1 minus I. So S is equal to 2 taken common, you write here 6 minus I by 1 minus I. We need to calculate the value of S. Multiply and divide. I mean rationalize to NR and DR, numerator and denominator. Write here 1 plus I by 1 plus I. So therefore S is equal to 2 into 6 minus I into 1 plus I whole by, of course it is 2. 2 get cancelled. So S value we are getting 6 minus 6 plus 6i minus I. So it is 5i minus I square, 5i minus I square. S is equal to minus I square meaning plus 1. So you can write S is equal to 7 plus 5i. So the value satisfies regarding the condition 7 plus 5i. So according to circle he given. So 7 plus 5i is there. S is equal to 7 plus 5i is there. Now S is equal to 7 comma 5 I am writing. And Q is equal to 8 comma 4 you can write. Q is equal to 8 comma 4. So R is equal to the circumradius of the circle is nothing but the distance between SQ. So 7 minus 8 whole square plus 5 minus 4 whole square over root. It becomes root 2. Therefore, locus you can write. Locus or circle directly I am writing. Locus becomes a circle. X minus 7 whole square plus y minus 5 whole square is equal to root 2 whole square. Or according to complex number, you can write like this. Z minus 7 minus I over modulus is equal to root 2 is the complex circle. Second option. Next one, 24th question. The area bounded by the curves argument z is equal to pi by 3 and argument z is equal to 2 pi by 3. Let us write the curves. Argument z is equal to pi by 3 and argument z is equal to 2 pi by 3 and argument of z minus 2 minus 2i root 3. Argument of z minus 2 minus 2i root 3 is equal to pi in the argand plane. Argument z meaning is theta is equal to tan inverse y by x. You should not give that these are not curves. You should not give the letter curves. You should mention the letter that lines. Because whenever theta is equal to tan inverse pi y by x given, it is pi by 3. You can understand theta is equal to pi by 3. So tan pi by 3 is equal to y by x. That implies y by x is equal to root 3. Therefore, the line is, you can understand as, it is a line passing through 0, 0, y is equal to root 3x having slope root 3. In the similar way, here you can understand theta is equal to tan inverse y by x is equal to 2 pi by 3. So what is 2 pi by 3 here? Tan 2 pi by 3 value tan 120. Tan 120 means tan 90 plus 30 minus cot 30 minus root 3. So here y is equal to minus root 3x you can write. This is another line which is passing through origin. Next argument of z minus 2 minus 2i root 3. Write like this. This is x plus iy minus 2 minus 2i root 3. Argument of this one, you can write now x minus 2 plus I taken common, y minus 2 root 3, y minus 2 root 3. Argument meaning theta is equal to tan inverse imaginary part by real part. Argument is equal to pi, that implies imaginary part by real part. So tan inverse of y minus 2 root 3 by x minus 2 is pi. We know that tan pi is 0. Tan pi is equal to y minus 2 root 3 by x minus 2. Y minus 2 root 3 by x minus 2. So it is 0. Therefore, now you can write y minus 2 root 3 is equal to 0. Therefore, you can understand here y is equal to 2 root 3. What is happening? We got the values that y is equal to root 3x, it is a line passing through origin, and y is equal to minus root 3x, it is a line passing through origin, and y is equal to 2 root 3, it is nothing but x-axis parallel line, it is nothing but horizontal line. Draw real axis. This is real axis. This is the parallel line of real axis. You can write here y is equal to 2 root 3 and put here 0 comma 0. It is a line passing through the origin having a 60 degrees angle. Put here this is pi by 3 with the positive direction of x-axis. It is the line y is equal to minus root 3x. This is the line y is equal to root 3x and this is the line y is equal to minus root 3x, which is passing through origin and having the angle positive direction of x-axis is 2 pi by 3. So first one is origin, put here this is A and this is B. A you solve with y is equal to root 3x and y is equal to 2 root 3. So y value we know directly, you can write 2 root 3. Substitute here root 3x. Root 3x is equal to 2 root 3. Root 3 get cancelled. So it becomes 2 comma 2 root 3. Now B, instead of y is equal to minus y, you can write y equal to minus root 3x here. So minus root 3x is equal to 2 root 3. Root 3 get cancelled. So x becomes minus 2 and y is of course it is 2 root 3. Area of triangle. Area of triangle OAB according to geometrical formula we know that x1 y2 minus x2 y1 over modulus, that is equal to 1 by 2 into x1 y2, meaning 2 2s are 4 root 3 minus x2 y1, of course it is minus of minus plus 2 2s are 4 root 3. So 4 root 3 plus 4 root 3 becomes 8 root 3. 8 root 3 by 2 is 4 root 3 is the area of the given diagram. 4 root 3 is fourth option. Next 2050 question. We have entered into locus source. Fifth question. Modulus of z is equal to 3. Modulus of z is equal to 3. Then the points representing the complex numbers minus 1 plus 4z lies on. Minus 1 plus 4z lies on. Minus 1 plus 4z lies on dash. Given modulus of z meaning x square plus y square is equal to 9. Let it be first equation, because modulus z is equal to root of component square plus component square. Let the locus point he is asking. So he is asking locus point minus 1 plus 4z. So write like this: alpha plus I beta. I am taking the locus point as alpha comma beta here, that he indicated with the letter minus 1 plus 4z. That implies alpha plus I beta. Alpha plus I beta is equal to minus 1 plus 4 into x plus iy. I meaning iota. So alpha plus here iota beta is equal to, you can write 4x minus 1 within a bracket plus I taken common 4 into y. Comparing real and imaginary parts. So alpha becomes 4x minus 1 and beta becomes 4y. Instead of x you take here alpha plus 1 whole by 4, and instead of y you can write beta by 4. Of course, sub in 1. Of course the point x comma y in the circle itself. So here I am going to discussing with you that let alpha comma beta be locus point. Alpha comma beta be locus point here. So that implies whenever you are substituting, you can get here alpha plus 1 whole square by 16 plus beta square by 16. Okay, we got here it is 1. So locus you can write. Locus, according to geometry, you can understand x plus 1 whole square. X plus 1 whole square plus y square is equal to 16. It is a circle. The locus is nothing but circle. So option is second option. Twenty-sixth question. If amplitude of z plus 2 by z minus 4 is equal to pi by 2, then locus of x plus I by amplitude of z plus 2. Amplitude of z plus 2 by z minus 4I is equal to pi by 2. Then the locus of x plus I by. Write like this. Amplitude of z meaning x plus I by. So write here x plus 2 plus I by here x plus I into y minus 4. Take rationalization x minus I into y minus 4 by x minus I into y minus 4. That amplitude is equal to pi by 2. So for two cases are there for the topic of amplitude. First case you can understand as tan inverse y by x, and second tan inverse y by x is equal to pi by 2. Y by x is equal to tan pi by 2, y by x is equal to tan, it becomes infinity, 1 by 0, taking cross multiplication, y by x is equal to 1 by 0. So whenever y by x is equal to 1 by 0, y by x is equal to 1 by 0, you can understand x is equal to 0 like this. This is case 1. Also this y should be positive because tan 90 infinity plus side, and another concept is there. Whenever the argument is pi by 2, you can understand it one as e power I pi by 2 cos pi by 2 plus iota sin pi by 2. So cos pi by 2 always becomes 0, so real part equal to 0, and I sin pi by 2 iota sin pi by 2 is equal to, because it is I, so it is greater than 1, it is not negative, so it should be greater than 0 like that. So real part is equal to 0 and imaginary part is greater than 0. That is the concept of the amplitude. Right here real part is equal to 0. Real part is equal to 0 comma imaginary part greater than 0. This is a concept already we have discussed in IP also. Or simply you can write tan inverse of imaginary part by real part is equal to infinity. I mean tan inverse of this is imaginary part by real part is equal to pi by 2. Any way you can do. Now tan inverse of directly amplitude I am discussing, which that real part equal to 0 I am discussing. So whenever real part is equal to 0, you can write here x into x plus 2 minus I. It becomes plus y into x plus 2 plus y into y minus 4 equal to 0. So this is a circle. You can write x square plus y square plus 2x minus 4y equal to 0. This is a circle. And another one, imaginary part greater than 0. What is imaginary part? Apply like this, x plus 2 into y minus 4. This one, x plus 2 into y minus 4, that to minus x plus 2 into y minus 4, next to plus I by x. So x y equal to not equal to 0, you should write greater than 0. Now multiply, first of all you write xy plus value minus of, multiply like this, xy minus 4x plus 2y minus 8 greater than 0. That implies xy get cancelled. You can write here 4x minus 2y plus 8 greater than 0. Divide with 2, you can write here 2x minus y plus 4 greater than 0 is the part of the locus. 2x minus y plus 4 greater than 0. Yeah, we got fourth option here. Next, let us discuss about 27th question. Seventh one, shortcut is there. If z is equal to lambda plus 3, if z is equal to lambda plus 3 plus iota 5 minus lambda square, I is nothing but iota, students, don't get confused. put. So what is the locus? Lambda. There is no question of condition for lambda is equal to real number or it is not equal to 0 or anything he did not give. So you can take lambda is equal to 0. So z is equal to 3 plus 5a. Z minus 3 is equal to 5a. So that's all. Z minus 3 is equal to 5a, not 5a, root 5a. Root 5a. So take modulus z is equal to root, of course root over modulus, take modulus. So I modulus is only 1. So root 5. I modulus meaning students component square only, not I square. Don't get confused. I square is equal to minus 1. You should not write I square is equal to minus 1 because component square means 1 square. Root 5. That's all. If you take, if you want to do the proper method, z minus 3 is equal to lambda plus I into root 5 minus lambda square. 2 times you should square both sides and get the answer. Next, 28th question is there. 28th question, locus of z such that modulus of z minus a whole square, modulus of z minus a whole square plus modulus of z minus b whole square. Modulus of z minus a whole square plus modulus of z minus b whole square is equal to lambda. Locus of z such that is equal to lambda. Real is locus of z such that. So this is a real he is discussing this. Now you can understand z is equal to x plus I by. So x minus a you write x minus a plus I by. X minus a plus I by over modulus whole square plus right here x minus b plus I by. X minus b plus I by whole square is equal to lambda. Everyone know that lambda whole square meaning real part whole square plus imaginary part whole square. Of course it is component square plus component square. So x minus a whole square plus y square plus x minus b whole square plus y square is equal to lambda. Locus of z such that x mod z minus a whole square plus mod z minus b whole square equal to lambda really is. Simply lambda you should say. If first option is there, you should not mention real. You should not mention real because if you expand this one, you can get here 2x square because x square coefficient y square coefficient should be same to get the circle equation. We got there is no xy term for the circle equation. There is no xy term. So you should not mention real. Simply find the locus. So 2 into, you can write here 2 into x square plus y square minus ax. 2 into x square plus y square minus ax minus by, that's all, is equal to lambda. So x square plus y square minus ax minus by minus lambda by 2 is equal to 0. This is a circle. Simply you can write this is a circle. So the locus is circle. This is a circle. 29th question. The locus of z such that z square by z minus 1. Z square by z minus 1 is always real. Is always real. Whenever he is discussing with that it is real. It meaning that it is not imaginary. Whenever it is not imaginary, you can say that the imaginary part is equal to 0. Therefore, directly I am writing imaginary part is equal to 0. Z square meaning x plus I by whole square. So x square minus y square plus 2ixy whole by x minus 1 plus iota y. So multiply with x minus 1 plus iota minus iota y by here x minus 1 minus iota y. Students, take only imaginary part, no need to take real part. So imaginary part is equal to 0. So minus I y into x square minus y square. Y taken common, y into x square minus y square, iota terminology. And here this is the iota terminology. So plus 2xy plus 2xy into x minus 1 is equal to 0. That implies among the two terms take y as common. So it becomes x square minus y square. Now this is minus symbol is there here. Minus symbol is there. So write here minus x square plus y square. Minus x square plus y square plus 2x square. That's all. And minus 2x, yes, equal to 0. You can write y equal to 0 is a point. Of course, the locus is y is equal to 0, meaning it is x-axis. And 2x square minus x square, you can write x square. X square plus y square minus 2x equal to 0. This locus is a circle having center 1, 0 and radius 1. It is also called as unit circle. X square directly given x square plus y square minus 2x is equal to 0. Now let us going to discuss 30th question. Question number 30. If logarithm of root 3 into modulus of z square minus modulus of z plus 1 whole by modulus of z plus 2 less than 2. Logarithm of root 3 into modulus of z square. Let us discuss the formula. Log x to the base a is equal to m. That implies x is equal to a power n. Log x to the base a. If we are eliminating logarithm, here base becomes base. So this base becomes this base. Now you can write modulus of z square minus modulus of z plus 1 less whole by modulus of z plus 2. I am eliminating logarithm. Less than root 3 whole square. Students, here base become base. So here base is root 3. You can write root 3 whole square. Root 3 whole square becomes 3. So you write here modulus of z square. Modulus of z square minus modulus of z plus 1 less than 3 into modulus of z plus 2. So 3 mod z plus 6. That implies modulus of z square minus this is 4 modulus of z minus 5 less than 0. Modulus of z square minus 4 mod z less than 0. Modulus of z square minus 5 modulus of z plus modulus of z minus 5 less than 0 by taking factors. Factorization. In the factorization I am taking common modulus of z. It becomes modulus of z minus 5 plus 1 you can take common. This is modulus of z minus 5 less than 0. So you can understand here modulus of z plus 1 within the brackets and modulus of z minus 5 less than 0. So modulus of z belongs to minus 1 comma 5 you write. Modulus of z belongs to minus 1 comma 5. Modulus of z belongs to open interval minus 1 comma 5. Modulus of z meaning x square plus y square over root of x square plus y square belongs to minus 1 comma 5. Of course, you can say modulus of z minus 5. This is not negative. Here negative meaning interior. Of course, only one value is there. Interior of the ellipse. In previous book, this is the correct answer. It's okay. Now, according to our options, you can say that locus is interior of circle because you can write z plus 1 plus into minus concept or minus into plus concept. You can take this one. Of course, this is positive. So modulus of z plus 1 x plus 1 whole square plus 1 like this. So take this one. So modulus of, if you are taking modulus of z minus 5 less than 0, locus is interior of ellipse. It is nothing but our S11 less than 0 concept exercise 1b in the circle chapter. Locus is interior of circle. Interior of circle. Okay students, 30 sums we have discussed. Next, somewhat easy sums are there. Let us going to discuss the 31 sum, from 31 sum onwards in next class.